Here is a second example of solving radical equations that's a little bit more challenging than what we're used to. If you're following along with the notes, this is worksheet B. This is example number 2. And we start off with the following irrational equation. So the issue here is that if we tried to square this, both sides, if we tried to do this thing, squaring this thing would be extremely messy. You would get inner terms that would not cancel out. The F and the L would, the radicals would cancel out, but it's just going to be too messy to do that. So instead of doing it that way, my advice would be to add this expression here over to the other side, so that we have 4x plus 1 equals 5 plus rad 3x minus 2. Now we can square both sides. And it's not going to be, this is not a perfect solution to the problem. This is, I'm still, when I FOIL this out, I'm still going to have a radical expression in it. But in my opinion, this would be the best way to do it. So now on the left side, this is going to be 4x plus 1. On the right side, we need to FOIL this out. So I actually have to multiply this by itself. And I got to, 5 times 5 is 25. 5 times rad 3x minus 2. And then there's another 5 times rad 3x minus 2. And then last but not least is plus 3x minus 2. The radicals of those, when you multiply them, the radical will disappear. So let's kind of clean this stuff up, see what we have. 25 minus 2 is 23, plus 3x plus 10 rad 3x minus 2. Okay, so I'm going to move all of this stuff to the other side. Maybe not the 10. We got to kind of see if it makes sense to multiply by divide by 10, but we'll see. We got to move that stuff to the other side. So I'm going to do that right now. So this is what I have when I move that stuff over to the other side, and what I can do now is square both sides again. That will be sure to get rid of any radicals now in this equation. Notice that when I square the right side, you have to square the 10 in front of the radical, and you also have to end up distributing that 100 now to the 3x minus 2, which creates some larger than expected numbers, but no big deal. We're all up to the task. And so what I've got is I've got a quadratic, and so I'm going to move all of this stuff to the other side, and bear with me. All right, so back to this little mishap. Sorry about that. And so we're going to minus that 300x, and we're going to add that 200. This quadratic is not for the faint of heart. But if you look closely, that the middle term is such a big value that you might see that 684, half of 684 is 342. 342 times 2 would be 344. So it actually ends up being pretty easy to factor. And we get two values. Now we got to check these to see if they're okay or not. So we're going to do that right now. So I pop these into my calculator, especially the 342, and when you plug that in, you get 37 minus 32, which is in fact 5. So 342, excuse me. Good answer. X equals 2, however, though, gives you 3 minus 2, which equals 1 and not 5. So 2 is an extraneous solution. And there you go. And, all right, here's one for you to try. Square root x plus 3. That's an x, not an alpha. Square root of x plus 3 minus rad 2x minus 11 equals 2. All right, try that one out and pause the tape and then come back in a moment. So I got as my answers x equals 6 and x equals 46. And we have to plug them into our calculator or plug them back into the equation to see if it works. X equals 6 works. You get 3 minus 1 equals 2, so that's perfect. And then 46, you get 7 minus 9, which equals negative 2, which is no good. So x equals 46 is an extraneous solution. Hope you enjoyed.